Hi, I'm hoping that you're having a good day. I am Mr. Carlos Joseph V. Manlapaz, your researcher, and I'm presenting to you my paper entitled Development and Validation of a 7E-based self-learning module in Science 9. My advisor for this study is Mrs. Angelina Pilumanlan, Master of Arts in Education of the College of Education in Pampanga State Agricultural University. So, for starters, let us have first a quick review of what happened in the Philippine science education way back in 2013. With the signing of the Republic Act 10533, which is otherwise known as the Enhanced Basic Education Curriculum Act of 2013, we moved from the old curriculum towards the new one. So, the old curriculum for junior high school was the secondary education curriculum wherein we offered or we taught integrated science as well as earth and space science for first years. And then we were offering or teaching biology for second year, which we now call as grade 8. And then we were teaching chemistry for third year. And then we were teaching physics for fourth year, which we now call as grade 10. Okay, so aside from the integration of these branches of science into each year, grade level now, which is from grades 7, 8, 9, and 10, we now also added 2 more years of senior high school. Junior high school science, its major aim is for these learners, for our learners to become environmentally, scientifically, and technologically literate. And for quite a while, way back in 2014, the results and findings of Kabansag, they're actually suggesting that stakeholders, that means parents, learners, administrators, and even teachers, believe that the changes in the Philippine science education, the changes in the science curriculum, they are preparing the learners they're better preparing the learners for the world, for a more scientific world. However, years have passed, and several international and local assessments are actually suggesting otherwise. One of them is the Organization for Economic Cooperation and Development's PISA. The Philippines, it ranked second lowest of the 79 participating countries in the 2018 PISA in terms of science. We are the second lowest. It was the country's first participation in the international assessment, and it was actually addressed by our Department of Education so much that we are now conducting Sulong Educalidad as our response to these international assessments. Another one is the result of TIMSS. With a score of 249, the Philippines, it was ranked last from among 58 participating countries in terms of science. Not only did the Philippines fail in science, it also failed in a similar field, mathematics, in the same international assessment. Now, we know that these international assessments are important, but what's more important are our local assessments, and even those, the National Achievement Test, are showing that there is a gravitation towards low proficiency in terms of science. And this was a report conducted and given by the Department of Education itself. Each quarter, the least mastered competencies were identified by each teacher in each classroom for, each class. And these least mastered competencies are just one of the many ways in which a teacher can identify whether or not the class is achieving greatly in terms of science. One of them is actually the mean percentage score. Each science teacher in the Philippines is enjoined towards the development of modules, the development of self-learning materials, of learning resources. And through time, various authors in the Philippines have already worked on designing modules that will enhance the student performance in the least mastered competencies, say for instance of Bina, Liantos, and several other authors. Also, some authors, they focused on some specific content, say for instance De Jesus in 2019. So these authors, they worked on improving as well the approaches of various modules. Now, why are we thinking that the modules are going to become part of the solution to the global problem, to the national problem of underachievement? It's because of the results of the findings of Cubillas as well as Unite and Basilan, in which they have remarked that there is a lack of teacher-made resources. And that leads to shortage of instructional materials in the Philippines. And that shortage will ultimately lead to the difficulty in delivering quality education to our learners. Also, the current learners that we are currently having in the in science in junior high school, they have been remarked by the validation by the evaluation of 10 in 2019 to be only satisfactory in terms of the value of evaluation, in terms of content, and they are not also very up to date. And according to Kapilitan, our current modules in science are they also contain numerous activities that are so unnecessary. On top of these problems, so these problems and these solutions, they all are emphasizing our current need for appropriately designed modules, as it was said by Arinto 2016. Arinto also added that since now have this new trend, which is distance learning, we have to make sure that our modules are carefully developed for distance learning. The country is currently under indefinite refusal to hold face-to-face classes due to the pandemic. And this refusal to hold these face-to-face classes is just one of the many measures that the Department of Education is doing on top of all of the other PPAs under the Basic Education Learning Continuity Plan that it has passed early this year, 2021. On top of this, since there are several distance learning modalities, say for instance, modular distance learning, online distance learning, and radio-based or TV-based instruction, as well as blended distance learning, there also now appears some problems on the digital divide in the country. Akamai 2017 as well as Winthrop in 2020 has remarked, both of them, that the country is still having unreliable internet connection. And there is now this severe technological divide. And that the Philippine education is very far from realizing its ICT for education objectives. And that resulted to the choice of our parents, of our learners, our major stakeholders, to choose modular distance learning as their preferred learning delivery modality. And specifically, in the results of the recently conducted Learners Enrollment Survey form of the Enhanced Basic Education Information System or EBEIS, of the Learners Information System or LIS, the kind of modular distance learning approach that our stakeholders in junior high school are preferring is printed modules. There now exists a new challenge to science education because of the pandemic. And now the teachers, according to our authors, they are playing this very big role in developing learning resources to address the learning needs of our learners. My motivation as the researcher of this paper entitled Development and Validation of a 7E-based self-learning module in science is that one of the two learning delivery modalities that we blended in my station is modular distance learning. I have seen the challenges that we have in online distance learning, and I'm also seeing the challenges that we have in modular distance learning, and now we blended them. And now I would like to address this by proposing the writing of the development and the development and validation of a 7E based self-learning module in science. Since it is the subject that I am teaching. Also, in order to deliver learning remotely through modular distance learning, I am seeing the development of this self-learning module to be responsive to the requirements of self-driven learning, which is an imperative to improve the academic performance in science of our learners. And what is more is that this module that I have developed and was validated will also be very, very operational, very significant in the delivery of face-to-face instruction once we have the opportunity to do so. So we now go back to these discussions, and we made clear our pointers on the needs on appropriately designed modules as well as our dilemma and the new challenges that we are now facing in distance learning. And though there are so many researches, there are so many authors who wrote about this already, about the development of modules, about distance learning, despite this rich literature that we already have in developing and validating self-learning modules in Science 9, there is still a need for a properly designed self-learning module which can actually function for modular distance learning. And it has to be one as well that includes all learning competencies for Science 9 patterned after the 7Es model. That is the gap. That is what we are still lacking. Now, I am Mr. Manlapaz and I am proposing this paper entitled The Development and Validation of a 7E-based Self-Learning Module in Science 9. And the development of this module, is working after the theory of psychological personal constructivism of Jean Piaget. We all know that learners are active meaning makers, and we are actually encouraging them to just do more meaning, just to create more meaning. We're encouraging them to just hold these tools, look at the world, and create their own meaning. We are deliberately exposing them, and they're also deliberately exposing themselves to various systematic processes of introducing new knowledge, and they are assimilating this new knowledge with their existing knowledge. That is just a very beautiful way of putting it. Our learners, they have this ability to integrate new learning with their prior knowledge. Though the integration may create some cognitive disequilibrium, it gets resolved in each step of learning. Those steps are what I am going to target. The current paper will religiously follow critical content requirements for each step in the 7Es method for modular distance learning and even for face-to-face instruction. It will begin from elicit, engage, explore, explain, elaborate, evaluate, and then extend. The learners will have an active role in the process of meaning making. The learners, when they are using the 7E-based self-learning module in Science 9, what I have in mind in developing it is that they will be using it step by step. And in each step, it will cause a new disequilibrium. It will ask these learners, our learners, to integrate that new information with their prior knowledge until the whole competency was realized. And what better way is there other than integrating the steps in the 7Es? For the concepts that will play very significant roles in this study, the very first one is we need to remember that the first concept we have in this paper is the development and validation of a self-learning module, of a 7E-based self-learning module to enhance the performance in science of our learners. Also, one more concept that I consider very important that we need to take note is that all of the learning competencies must be included in the content validation. Also, the 7Es approach must be incorporated in each lesson. It's very significant. Also, the learners must become active participants in the learning process. Kailangan, the module is actually requiring these learners to do the work. It's not like the module is doing most of the work already. The learners must do the work. Also, there is a need for a panel of experts to verify the validity of the content, as well as the general validity of the content, of the design and format, as well as the pedagogies made in the module. And lastly, the last important concept is that there must be valid tools, instruments, rating sheets that must be used by the evaluators in scrutinizing the learner's module. So these concepts are making up the framework of my study of this paper, and they are working in the steps of the following paradigm. So we have here the three parts, the three major stages of the paper. The first one is the development stage. The second one is the validation stage. And the last one is the output of the paper. For the development stage, we have I have conducted the following activities in the preliminary phase. and then in the preparation phase, in the planning phase, and in the design phase. For the validation, it will solely become the validation of experts using the evaluation rating sheets for DE and ODEL modules in terms of content, in terms of design and format, and in terms of pedagogy. And then that will ultimately lead to the output of this paper, which is the 7E-based self-learning module in Science 9. Now, the research problems, the general statement of the problem is the development and validation of a 7E-based self-learning module in Science 9. But specifically, this paper aimed to answer the following specific questions. The first one, how may the self-learning module be developed? The 7E-based self-learning module be developed? And how may the evaluation of the 7E-based self-learning module be described in terms of content, in terms of design or format, and in terms of pedagogy? Now, given the research problems, the following research design is going to be used for this, was used for the study. The current paper was crafted after the research and development design, wherein sufficient facts and processes were acquired so that they can be translated into better articulated learning resources, including this self-learning module. Now, for the evaluators of this paper, there will be two sets. The first set of evaluators are called subject matter experts, and they are identified through purposive sampling. They served as authorities in the identification of the essential and non-essential content for the 7E-based self-learning module in Science 9. These subject matter experts are experts in the field of teaching and learning in Science 9 that are affiliated with some external institutions from public school teaching stations in the divisions of Pampanga and in Angeles City. The second set of evaluators are called validators. They are 7 evaluators which were identified through purposive sampling. They will be critiquing the developed 7E-based self-learning module in Science 9 based on its usability and its compliance to educational requirements for print resources. So this group was composed of a master teacher, a science department chairperson, a learning resource coordinator, 2 education program supervisors for science, and 2 school heads who specialize in science education. Also, these evaluators that I had for the paper, they must have at least a master's degree. For the next part of the presentation, we will be discussing the instruments that I used in the paper. So the first instrument that was used is the evaluation instrument for content validity for DE and ODEL modules that is adopted from the Pampanga State Agricultural University's Graduate School College of Education. The tool enumerated all of the learning competencies for Science 9. They were subjected to categorization as either essential or not essential content. The second tool that was used in this study was the evaluation rating sheet for the DE and ODEL modules. So the factors that we considered for the evaluation, for the validation, were the following. First, content. The second one is design and format. And then the last one is pedagogy. I would like to emphasize that this tool was adapted. It means that I removed the technical and the technological aspect of it because I am not developing an self-learning module. It is a print module. The tool generally contains all of the requirements for distance education modules and even for face-to-face modules with a simple rating of yes or no to describe the presence or the absence of a particular criteria under each factor. For the last part of this discussion, which is on the procedure, we have conducted the following steps. So initially, the learning competencies for Science 9 were enumerated and the general lay of the module was already mapped. The learning resources, reference books, and other materials that are either print or non-print that can help in the development, in the writing of the 7E-based self-learning module in Science 9 were already collected. Also, there have been requests already for permission to adopt and adapt the instruments and the rating sheet from the Pampanga State Agricultural University. It was already sent, and a reply approval was already received. It is actually included in the manuscript's appendices. Also, the subject matter experts identified the essential as well as the not essential learning competencies for the 7E-based self-learning module using the evaluation instrument for content validity of DE and ODEL modules and the LOSHI or the LOSH table of minimum CVR values. For the identification of the CVR value for a particular learning competency, the following formula was used. It is CVR is equal to E over N divided by 2 divided by N divided by 2. N, it refers to the total number of the validators, of the subject matter experts who were involved in the content validity of the module. E naman, it refers to the number of the subject matter experts who voted for a particular learning competency to be essential. Now, the LOSH table for minimum values of content validity ratio is shown now on screen. So as we can see there, the number of panelists that were involved as subject matter experts in the current study are 12. So the minimum value, the minimum CVR value, based from this table, for each learning competency for them to become essential, must be 0.56. The next step, step number 4, the 7E-based self-learning module in Science 9 was already written. And the next step upon the completion of the writing of the first draft was the first validation. All 7 validators used the evaluation rating sheet for DE and ODEL modules with the following factors: content, design and format, and pedagogy. And under each factor are criteria, several criteria. The next step, step number 6, there was a full agreement among all 7 validators in all criteria under each factor of the evaluation rating sheet for DE and ODEL modules in the first validation. And this meant that the validation stage of the paper is going to conclude. It's completed because all 7 of them have already agreed in each criteria under each factor. Thus, the next step was the final draft was sent to the English critic for final critiquing. The English critic is already done in critiquing the final draft of the module. It was thus printed already, and a certification of the grammarian, the English critic, is attached as part of the appendices. The next and last step is the results and their implications were thoroughly processed for panel discussion prior to this presentation. And then now is the final panel discussion. Now, what we are doing here now is the final presentation, the final panel discussion. Let us now discuss the results of the findings, the results and findings of the 7E-based self-learning module in Science 9, the conduct of this study. The first of our 2 research problems, specific research problems, is the following. How may the self-learning module be developed? Based from table 1.1, which we're presenting the phases of the development and the validation of the 7E-based self-learning module in Science 9, we see the activities and the description of the preliminary phase of the development stage. Based from this table, we see that there were gathered print and non-print resources and references. Also, the content and performance standards were already reviewed for Science 9, based from the Science grades 3 to 10 curriculum guide. Also, the subject matter experts and validators were already identified. For the preparation phase, we were able to accomplish the following activities with the following description. The consent from the subject matter experts and validators were sent through communication letters. Also, the permission to use the instruments for content validity and rating sheet was already sent, and the reply and approval was already given back. Also, it followed the download of the instruments. The next phase is the planning phase, wherein the learning competencies for Science 9 were already identified. Also, the Science 9 subject matter experts, they already conducted the validation for the essential and not essential learning competencies through the following tool. After such validation of the content for the 7E based self-learning module in Science 9, followed the finalization of the content based on the Losch table of minimum values for content validity ratio. The next phase is actually going to be discussed later, but we need to pause here because I would like to report the following findings too. Let us be reminded that the number of panelists that were involved, the number of subject matter experts involved in the study are 12, and that requires a minimum value of 0.56 for the CVR of each learning competency. Science 9 originally has 39 learning competencies, and of these 39 learning competencies, 30 are essential and 9 are not essential. One competency from the first quarter is not essential. 2 competencies from the second quarter are not essential. And then 4 competencies from the third quarter are not essential. And then for the last quarter, 2 competencies are not essential. Following now is the design phase. So the content was already mapped into units, and each unit was divided into several sections through the laying out. Also, the 7E based self-learning module in Science 9 was already written. It was conducted. It already commenced in this phase. Now, for the validation stage, we only have one phase here, which is the first validation. So as it is noted, the validator's validation of the content, of the design and format, and of the pedagogy of the 7E-based self-learning module in Science 9 was done through the evaluation rating sheet for DE and ODEL modules in this phase. For table number 1.2, we are presenting now the learning competencies on the first quarter biology in Science 9. And as we can see, of the 6 learning competencies, one of them is not essential, which is describe the location of genes in chromosomes. According to subject matter expert number 2, this learning competency, which leads to the lesson on gene location, should be a lesson in grade 10, and thus it is not essential for Science 9. Table 1.3 is showing us, it is presenting with us the results of the validation for the quarter 2 learning competencies. And of the 10 learning competencies, 8 of them are essential and 2 of them are not essential. According to subject matter expert number 3, the lesson on Bohr atomic model should have been taught in Science 8. And so if they actually added, so subject matter expert 3, they added that it is going to be duplicated in case the writer, your researcher, is still going to include this topic in the 7E-based self-learning module. And that is actually what we are avoiding, duplication. Table number 1.4 is presenting with us the learning competencies on the third quarter for Science 9. And according to this table, we can deduce that of the 10 learning competencies, only 6 are essential. 4 of the learning competencies, learning competency number 1, which is describe the different types of volcanoes, learning competency number 8, which is infer the arrangement of stars in a group, constellation does not change. Learning competency number 9, which is observe that the position of constellations changes overnight. And then the last learning competency for the quarter, which is learning competency number 10, show which constellations may be observed at different times of the year using models. These competencies are considered not essential. Subject matter expert number 2 has commented that the lessons on constellations should be integrated in Science 8. should just be integrated in Science 8 because they are too simple. They actually remarked that they could have been one of the topics presented in Science 8 wherein the comets, asteroids, and meteors were discussed. Table number 1.5 is presenting with us the learning competencies for the fourth quarter, which is on physics. And according to this table, according to the data presented to us, of the 13 learning competencies, only 11 are considered essential. Two of them are not essential, learning competency number 2 and learning competency number 8. According to subject matter expert number 9, learning competency number 8 could be integrated in learning competency number 7. And if we read learning competency number 7, it says, perform activities to demonstrate conservation of mechanical energy. The same thought, which is the total mechanical energy remaining the same, which is on conservation, they're actually similar. And so the point of the subject matter expert number 9 is actually taken. Those are the tables for the that are answering the first specific question, the specific research problem that we have in the current paper. How may the 7E based self-learning module in Science 9 be developed? Our conclusion for the tables that were already presented are the following. We can therefore conclude that based from the data and the findings presented, that the 7E based self-learning module is a print module that is developed following the observe, ask, gather information, associate, and communicate modular approach, which was developed by Istuningsi 2018. The learning competencies were validated by 12 subject matter experts through the evaluation rating sheet for DE and ODEL modules. This provided the basis for identifying the lessons and activities that must be included in each learning competency content validity ratio, which was measured against the Losch table of minimum values for CBR. Losch 1975 has commented that by validating the content of a particular module by experts, that provides the validation. That validation provides supporting evidence that the 7E based self-learning module in Science 9 is fit. It has adequate content for the learner's needs. This ensures that the content for the 7E based self-learning module in Science 9, they're valid. They're backed by expert validation. For the next phase, what we are now going to present are the results, are the findings that will answer the following specific question that we have as one of our specific research problem. How may the evaluation of the self-learning module be described in terms of 1. Content, 2. Designer format, and 3. Pedagogy. Table number 2.1 is presenting to us the results of the validation for content. And as we can see, we are only presenting the findings for the first validation because we already have had full agreement. Based from the data presented in this table 2.1, we can deduce that the 7E based self-learning module in Science 9 has met all of the standards in terms of content for a learning material. With the full agreement among the 7 validators, that is the result of our content validation. There is a commendation from validator number 1 who commented that the links are operational. So our validator number 1 has actually tried them out. And also they commended that there is this presence of the reference sections, which is indeed going to support the students, guide the students for further research activities, which is our third criteria for this factor. For the next factor, we have the validation of the design and format, wherein 5 different criteria must be satisfied. And based from the data presented in this table 2.2, all our 7 validators for the paper, they have concluded, they have agreed that the 7E-based self-learning module in Science 9 has met all of the standards for a learning material in terms of design and format. Validator number 6 actually commented or added that there was this optimization of the use of underlines, the use of italics, the use of boldface, and even highlighting several words. It was actually off the record commended that there is this existence of glossary, which is making the general design, the general format, the consistency of the format of the entire 7E-based self-learning module very commendable. For the third table in this phase, we have table number 2.3, which is the validation of the pedagogy. And in this factor, we have 7 criteria that must be satisfied. And indeed, the 7E-based self-learning module in Science 9 has met all of the standards in terms of pedagogy for a learning material according to the result of the validation. All 7 validators agreed that all of these criteria that will make a learning material an excellent learning material in terms of pedagogy are present in the 7E-based self-learning module in Science 9. And thus, in all of these factors, from content, design and format, as well as pedagogy, there is no more need for a second validation. Based from these data that we have presented, we can now conclude that all the 7 experts that validated the developed self-learning module, 7E-based self-learning module in Science 9 in terms of content, in terms of design and format, and in terms of pedagogy, have reached full agreement in the first validation cycle. Thus, the 7E-based self-learning module in Science 9 satisfies all the standards for a learning material. So these conclusions are made, and the following recommendations are going to be brought up on the table by the researcher, yours truly, Mr. Carlos Joseph Manlapaz. Among the first among my recommendations is that the 7E-based self-learning module in Science 9 could be utilized in actual instructional processes so that it can promote scientific, environmental, and technological literacy among grade 9 science learners. The second recommendation is that there can be a further evaluation of the 7E-based self-learning module. It can be done through some experimental research design. Since the current paper has focused on the research and development design, a similar study can be conducted using this module, but that time is going to be using it for experimental research design with a control group and an experimental group. And the last among my recommendations as your researcher is that the 5 steps: observe, ask, gather information, associate, and communicate, which were proven effective by Galea and Siswoyo 2015, Istuning C et al. Of 2018, as well as Octavianti, which was already proven to be effective, could be integrated in other learning areas too, such as Science 10, Science 8, Science 7, and even in other subjects, say Filipino, English, and MAPE, as well as other fields. The 7E-based steps: observe, ask, gather information, associate, and communicate is therefore proven to be effective in developing modules, just like the 7E-based self-learning module in Science 9 developed through this paper. So, I am hoping that you are sharing my glee, you are sharing my celebration of science, my celebration of science education. And I am hoping that through this presentation, I was able to let you know the results and findings of the various steps and the various evaluations that were done in the making of the 7E-based self-learning module in Science 9. Special thanks are given to the partner subject matter experts and validators, as well as my advisor, my statistician, the members of my panel, my English critic, and all of the friends, colleagues, and even everyone who were not initially connected to me. Say, for instance, we did not really talk before the conduct of this paper, but we shared mutual enthusiasm in the conduct of this paper, which will result to a tool, to a module, which can be used by our learners, by our Science 9 learners in making their academic performance in science better. This has been Mr. Carlos Joseph V. Manlapaz, your researcher, and I am hoping that you are having a very pleasant day.